Okay, thank you. Okay, my name is Jaeyoung Choi from Sungsil University, Seoul, Korea. Actually, Korea is an opposite place from Brazil. There is that 12 hours time difference. It takes more than 24 hours to arriving from Seoul to this Rio de Janeiro. Anyway, okay. My topic is Freetype Metafont module, and this work is collaborated with Amar Ul Hassan and Geunho Jung. Okay, this is the content of my talk. I mean, before I present that kind of Freetype MF module, Metafont module, I want to explain what is that motivation. It's that kind of a long story. Anyway, you know that what is the font, what is the text, what is the rasterizer things. I mean, that is the text is represented by characters. Each character represents a font file, okay? But in order to display that font on the screen, everything should be rasterized, okay? There are lots of variations of font, but I want to skip that basic things. But there is a kind of programmable font that is called algorithmic font. The characteristic of programmable font is that, I mean, the typefaces, even family of typefaces, are described using program to generate the typefaces. This kind of algorithm may be parametric, okay? With some kind of developing, I mean, the changing parameters, then it may be possible to generate various font, okay? I mean, font families including standard, italic, bold, italic bold. The most famous thing is the CSD and Metafont, okay? The advantage of this program font is that it provides to process font parameters, possible to generate various font styles, various styled font by changing parameter values. But the problem is that it's not easy to develop the kind of font program with various font parameters. Also that even font designer is not easy. Also the programmers cannot develop that font. Okay. But Knuth defined the Metafont. Metafont is kind of program language to generate derivative font based on basic skeleton of font. The key factor is to determine the shape of the pen and its trace of the pen, okay? They easy to generate various font styles by separating pen and trace. Advantage is the easy to generate font by designing pen and the curves, the small memory space, okay? Possible to generate various font. But the problem is that it's very difficult for font designer to use them. It takes lots of computing power, okay? It's slow processing speed since batch processing of a whole character is required. Difficult to program Metafont, and then no visual editor, and then lots of disadvantages. Okay, what's the problem of using Metafont? I mean, with using GUI, okay, it's difficult to make many changes. It takes lots of time and cost to create a new font with Metafont, okay? So font is not familiar with outline font with parameters of Metafont. That is that font designer things is that they change it in some kind of a control point of each things and then generate it. Also that even that one of the Korean characters, it has lots of control point, and then that font designer change that details of that, some kind of details of that font position. Okay, I mean, I'll briefly explain what is the OpenType. OpenType is developed by Microsoft and Adobe together, okay? But later Apple and Google joined them. Actually, the MM has the old story. They define the 4 extreme things, and then they can generate the middle of the things. Okay, that is that multiple meta font. But 2 years ago, that OpenType is defined. That is all of the control point can be defined, and its movement. And then with this movement, the various the styles can be generated directly. So, for example, for this is a thick hue, and then this one is thin. Then each it defines the movement of this control point, and they can be generated. So that is that representative things. There's a 3 axes of width, thickness, weight, and then they can define it, and the people can use it. If we want to add one more axis, then you can change the various font. But the problem, okay, that is totally different thing. Okay, Roman characters, okay, alphabet. It only, people can design only 200 characters only, okay? It's so simple. It develop time is 3 to 4 months, and then cost is, for example, $20,000. So there are a bunch of font available, more than 100,000 styles of different font things. Size is small and mark is too large. But the problem with CJK is Korean, that is Chinese, Japan, Korean. Usually that Hanja is a Chinese character and Hangul Korean characters. Okay, Korean characters is composed of more than 11,000 characters. Chinese characters is more than 20,000. Usually the total is that I heard that 40,000 characters. The develop time is more than 1 year. Cost is a lot more than 10 times. So the variation font is quite limited compared with Roman characters. I want to mention that, okay, because the Metafont is quite a good algorithmic font, but the Western people, based on Roman characters, do not need to develop algorithmic font because it's easy to develop compared with CJK. Okay, I'll explain what is UFO. UFO is that unified font object. Everything represents outline font defined in XML. So for this kind of characters, all of the control point can be represented by the XML kind of styles. Okay. So if we represent some kind of Korean characters, everything is defined as kind of XML styled position of font. Okay, we defined something here. So we define the XML kind of things. We want to add some attribute. Okay, for example, pen pair. If we want it a little bit thicker, then this is pairing together 2 positions and pairing. If we want to enlarge it, then it can possible to do it. So inner type defend function is that if there is some point, then if we kind of enlarge it, the other point need to follow that movement. And also serif, round, and corner, we define it, and this is a kind of vowel of Korean font called R. This position defines something, but we added some of that attribute here. Then with adding attribute, we can add some kind of things here. Okay, this is that all things is a kind of adding attribute, added attribute. So with this with this, and then kind of UFO to MF, UFO to Metafont, we converted everything to the Metafont, and then we can generate other different styles things. So I show that. Okay, so we define some of that new product called stem font from Metafont. Okay, that is that kind of intermediate file format, and then this is kind of lightweight, and then we are going to develop the interpreter that is lightweight based on kind of a smartphone and the tablet kind of things. And then with this, if some parameters, it can directly generate new characters by changing some of the parameters, okay? But in older days, it takes lots of time to develop it. The reason that it's possible right now is that computing power is much faster than before, okay? This is a kind of a top 500 edition. This is that world most fastest computer in the world. Okay, that is that 1997. It was at 1 teraflop. 10 years later, that computing power was at 1,000 times faster, and 10 times. I mean, almost right now that is that exaflop machine that is 10,000 times faster than 10 years ago. That means that when the Metafont was defined, okay, the computing power is more than 1 million times. I mean, 10 to the 9 power maybe. It's much faster than before. So that means that computing power is fast enough to support, to develop that kind of things. Okay, this is that kind of small demo developed last year. So this is Korean characters, and each point we kind of pairing things, and then some kind of horizontal pairing and vertical pairing, and we want to add some kind of glyph attribute. Okay, we want to add some glyph there and here, that kind of things. Kind of depend function. If you enlarge that one, and then you need to follow, and this point need to follow that to get at the same time. And then we added some of the attribute, and then this is that kind of fun sample characters. And then with this, we can adjust that stroke. Okay, that is that little bit lightweight. You are not familiar with what it means, but anyway, that each one is a characters. We want to adjust the stroke weight a little bit heavier, like this. This is stroke contrast. We want some kind of vertical lines is a little bit thicker than before. I mean horizontal lines. Yeah. The next one is the vertical lines should be thicker, like this. But this one is based on Metafont. Okay. We added sheriff here. Here we added some kind of thing here, right?
So is this running Metafont in the
Yeah, because each time
so
adjust it and then computation. Adjust it takes a little time, maybe
yeah, you see the
10 second, 15 second delays, but
the delay.
yeah, right.
But yeah, still impressively fast. Okay, but as you said,
not everything that is called the sample characters only. Yeah,
small number of
right.
characters, yeah. Still.
Everything's fast in Korea.
Yeah, maybe.
And then
sometimes we will do this on a phone, just on the cell phone.
Yeah.
Yeah, of course. I mean, this is getting
okay.
faster and faster.
So the point is that we define that kind of it's possible to use that Metafont and then generate various kind of styles. Okay. Then, what's the motivation of this work is that we want to use Metafont directly on the rasterizer. Okay. So currently, that Freetype is that kind of free sheriff true type that it generated all of the things, but it's predefined, already compiled one. But our things is that Metafont from original things with changing parameters, all of different styles font can be generated immediately. So we want to use a Metafont in Freetype rasterizer directly. So we don't want that to pre-convert Metafont to outline font for Freetype rasterizer. Okay, use MF file like TTF files. Just use Metafont like general digital font because we have the high performance and high quality. We want to generate it, and then we change the font styles with user preference. User can easily change font styles just by changing the parameters, parameter values. But with this, one of the Metafont file, with style parameters can generate it directly. Okay, so that is it. Related work with VF library, virtual font library that is maybe 2008, developed by one of Japanese guy because Japanese character lots of font styles. They want to define the unified API for all software font things. So the point is that with this concept is that add, remove driver module conveniently and link them to the rasterizer. Okay? But the system is too heavy for embedded system because that you need to maintain that VF lab cap is kind of database in the inside of the rasterizer. And then 2 years ago, okay, I present this work at TUG conference at where? That is at Toronto, right? I mean, this work is that MF config Metafont plugin module for Freetype rasterizer. But thing is that from application direct code that font config, okay? If it figure out, okay, that is Metafont, it bypass it, okay? Then MF config can generate it, and then it generated all of the things, and then pass it to the generated bitmap font, and then show, generated true type font, and then pass it to the Freetype engine. But it is really slow. I can show that performance later. So this time, I want to use that Metafont directly to the Freetype engine. So although the Freetype is open source, but it doesn't provide modules or interface to add new features. It only supports outline and some bitmap font, TrueType, Type1, OpenType, Windows, not everything, okay? No support of parameterized font like Metafont. So we want to add this Freetype with new modules, okay? That is that when we design that Freetype Metafont module, 3 things should be important. It needs to support Metafont, okay? Second thing is that there is no dependency. Also, it requires a high performance kind of real-time generation. The third goal is that easy to install. If that is difficult, replace rasterizer is a problem. So that is installation is quite important thing. Okay, then this is architecture in the Freetype rasterizer, and then the kind of high-level interface, base layer, low-level interface. Then, if there's a Metafont, then it passes the Freetype MF module, and then this module is composed of 3 modules. There's a linker module, administrator module, and transformation module. Okay, linker module receives the Metafont, and then it takes the Metafont request, passes it to the administrator module, and it has that searching. If that already exists, then it bypasses it. If it doesn't, then go to transformation module, and the Metafont file is transformed to the outline font inside of the Freetype. And then it go to the administrator module and store some of the places, and then pass it to the Metafont request, okay? The 3 modules, and the experiment. Okay, that is in the client application, input a Freetype to display font style text on screen using X Windows system in Linux, okay? It displays the text using Metafont file. Metafont, one Metafont, font name is that the modern sample text comprised of 300 to 400 words. That is at 1,500 to 2,000 characters, okay? It uses some of the parameter values, we use it. And then for the experiment, and then this is computer modern normal font. This is a come to modern bold font that is at different styles. For the experiment, we use some kind of data set that is free serif font families. And the bottom one is that data set, to generate by the computer modern directly inside of the Freetype. Okay? Then the performance thing is that this is the true type driver time. Usually every time is 3 milliseconds, 3 to 5 milliseconds. But 2 years ago, with MF config time, that is that more than 20 times. Okay? But this year, inside the Freetype Metafont module, it takes a kind of 6 milliseconds, 7 milliseconds, little bit more than twice, but it's okay. It's acceptable time, I think. Okay? So the result is slightly slower than default module, but because it converts Metafont inside of the Freetype. Okay? Convert Metafont, it corresponds to outright font. The result much faster than the old 2 years old result because it is implemented directly inside the Freetype and not dependent on any font families. This test demonstrated that Freetype Metafont module performance can be considered as excellent even though it has linked to external program and Freetype. Okay? That's the end of my talk.
Questions?
There were attempts earlier to do parametric fonts, right?
Yep,
So the Panos number, for example, you heard of Panos number?
Panos number?
Yeah.
Panos number is what?
There was a company called Panos Systems many years back.
I don't know that.
So they have a 10-digit number.
Uh-huh.
So ascending. So, but that's more for Latin characters. Because
Right.
That's more where they have a tradition
Mhm,
of serif.
mhm,
So here, is there a tradition for serif or is it a different thing?
It's a serif, Korean character, Chinese character, totally different from Latin. Even the Korean Chinese are different. Different parameters. You need to define that different.
These strokes you find, they have a different this thing, like they start with TeX and then become 10. So these strokes are different, right?
Yeah,
so,
right.
So looking at separately those elements, is there a model you form for them?
At this moment, no modeling, but later we can add more parameters to define the thickness.
So now you only go for square,
Straight,
square shapes,
right,
rectangle
right,
shapes.
right. But this is like the basic things, but you can add more attribute later.
So this is amazing, I think, this work that you're doing. Is there a way to extend this to Indic fonts as well, or are you, as of, or is that additional? Because I guess in part of, right, so Sanskrit and derived fonts, there's a lot of ligatures, for example, that I would assume that would have to be somehow incorporated into the designs. I'm just curious if you have done any kind of preliminary work on in that field.
This is just one sample of Korean characters, okay? That is a Gothic style. If we are trying to the Ming style, it takes another time. Okay, this is one example, and currently we are working on Chinese characters, but it takes time and time. I don't know how long it takes. Currently, one of my expert researcher, he spent 1 hour to adjust one Chinese character. So it's amazing thing.
A couple of hours then,
Just one character.
Actually, on that, right, so the Chinese characters, right, they're tens of thousands of characters, but they're only about I think about 200-300 radicals.
Yeah, right.
Do you somehow combine it do you somehow work on the radicals and then there's some kind of algorithm for combining the radicals? Is that, or do you actually sort of set each character separate independently? I'm curious.
Yeah, that's the question I want.
Sorry. Even though that Korean character is kind of combinations of vowels and consonant, but it's much simpler than Chinese. Okay, but for the what kind of art kind of things, the font designer need to adjust a little bit. I mean, not the regular rules. Okay, each thing can be generated some kind of art with the art concept. So even the Korean things, when we develop that, I mean, the same thing can be applied at similar positions. We cannot take all of the details more than 10,000 characters, 20,000 Chinese characters. It's impossible. But we want to apply, if we have some problem to apply that there, then same thing can be applied at all of the places. But not only that, it's impossible to only the 30 radicals only, but it's much more than that. But yeah.
So, Metafont has this API for callbacks on the outlines, right?
API go back to outline. That is that we use that MF tracer inside of the Freetype.
So because you said that you converted the Metafont to an outline.
Outline, yeah, inside, yeah.
But so the user cannot have access to this conversion. If I want the outlines.
Right.
He can.
Right now, no.
Okay.
Right now, that Metafont, if people want to use it, that Metafont is already converted to TrueType. Then people use that converted TrueType. But our thing is that we can use that Metafont directly to the rasterizer, then inside they convert it.
Okay. Thank you.
Thank you.